I have to draw the DNA somewhat larger, say like that. In this DNA, there are the base pairs, which I'll draw like that. You see? And it's these base pairs that control, it's the base pairs that control the creation. The creation, they contain the instructions. They contain the instructions which run the program to create these polymerizations. What's being polymerized is protein. The protein is being polymerized by this basic formula. I call it a formula. DNA, RNA, protein. Actually, I don't call it a formula. I call it an equation. It's not an equation in the strict sense, but I call it an equation. And it's from these instructions, according to this formula, if you like, where the DNA sends messages to the RNA. The RNA takes these messages, goes to the ribosome, and in the ribosome is created the protein. Now the problem happens is that the DNA, for some reason, let's say, loses its messages. Somehow they fall out. The DNA is not able to repair or replace these messages, and now we're stuck with holes. These holes are called the mutations. And now when the DNA says something to the RNA, the message is all mixed up. The DNA opens, let's say, tries to transcribe this message to the RNA, but the messages are gone. Or some messages are there, but not enough to prepare the protein in the right way. And then what you have is infection. Of course, the most serious infection is, of course, cancer. Well, what do? Well, we repair the mutations. But how do we do that? Well, it's simple. We introduce a compound. We'll draw it with this arrow. This compound is able to get to these locations on the DNA. It's able to get there, and if we have holes here, what we call these holes are, they're mutations, of course, but they are unoccupied states. Unoccupied states. What kind of unoccupied states? They are unoccupied quantum states. And now, what about the arrow? What about the compound? What about this compound? Well, yes, you could say it's a medicine, and it is. This compound is a Fermi particle. And you say, well, what is a Fermi particle? And they'll tell you a Fermi particle is a particle with spin half. And if there are available states for this Fermi particle to go in, it will go in. See? We get our DNA DNA message back. If the compound sees states that are occupied, then this compound will not go in, because the material in the DNA can be considered as a Fermi particle, and this particular compound will not interact with states that are already occupied because of simply the polymerism. And since it won't interact with the states that are already occupied, then you don't have any side effects. There are no side effects. There are no side effects with this compound because the compound cannot get into states that are already occupied. Now comes the question, well, what's in the compound? Well, obviously, not gold. Not gold, not a metal, because that's not what's in there to begin with. And if you know what the makeup of the genetic code is, of these genetic base pairs, it doesn't take a real genius to figure out that this compound must be something that will fit. And simply the DNA uses this compound to rebuild itself. And what you have then is that now with the base pairs back in, the DNA will go on to make the protein in the proper way, and the regulatory protein will come back, operate on this DNA, and the DNA will create new and better DNA, and that DNA will again in turn create new and better protein, and that protein will come back and operate on this new DNA, and you'll have an even better DNA until this process continues to such a point where all of the DNA has been repaired, and now all of the various parts of the cell are totally replaced. And that's very simply how it works.
So the cancer is cured?
Yeah, we'll get to that. I can draw you a picture. What you have, let's say, in red is an infected cell. The cell is infected. The DNA in the cell produces cancer protein. They call it polypeptide. Actually, you have polypeptide markers. In our tests, before the patient used the medicine, his polypeptide marker was 137, way over the limit. I mean, he had a big tumor. He used the compound for, say, 5 months. But after 3 months, this marker went down to 43, below the critical level. And after 5 months, it went down to 1.0, which is virtually no polypeptide at all. What happened? Well, the compound entered the cell and simply transformed this cancer cell into a healthy cell. No side effects. No side effects. We didn't kill any cells. We killed nothing. We killed nothing. all we did is transform the cancer cell into a healthy cell, back to the way it was. We simply reversed the reaction. Of course, we added the compound that I keep talking about. The compound got into the DNA. Why? Why did it do that? Because the compound has the right molecular weight, and more importantly, has the right spin. The right spin, because this is a spin-spin problem. This is a spin-spin problem out of physics. Plain and simple. How did this compound see that DNA? You simply write down de Broglie's expression. P is the momentum. Let's say mv. M is the mass of the compound of V. You can calculate that from body temperature. C squared over 2m is the kinetic energy, which is equal to 3.5 kg. K is the Boltzmann constant. T is the absolute temperature plus body temperature, 37. You do the calculation, lambda comes out to be 10 to the minus 9 meters. And 10 to the minus 9 meters is exactly the order of a DNA molecule. So that this compound will interfere with the DNA molecule. The compound will go into the DNA molecule. The fancy word for that is intercalation. From the verb to intercalate, which is a fancy word for the word to insert, which I didn't know before until I read it in a book. And it's that simple. It's that simple. But they don't do it that way yet.
So what in the medicine?
Well, that's a good point. I said earlier, it has to be compatible with what's in the DNA. See?
And you said it's not medicine.
Sorry?
It's not medicine.
Well, it's not gold, is it? I mean, we don't find gold in here, do we? We don't find other metals. We don't find anything. Obviously, what do we got? We got some carbon. Forget about that. We have some other compounds, but of course, what's the big player? The big player is nitro. Nitro is a Fermi particle. Fermi particle again means spin half. Nitro is spin half. You can put two nitros together, but try to put three. Forget it. It won't happen. It won't happen to put three nitros together. Like they say, on top of each other. It won't work. They will repel. So what's in here is Fermi life. It's Fermi life. And so therefore, if you try to put something in there that is also a Fermi, it's also identical and indistinguishable to what's already in there, it won't go in. It won't go in, so now no side effects. And that's the key point. If it were a boson, we'd have another problem. So, are you happy with that or what?